Thank you. We can go straight to the paper of discussion today. This is my Kabarak, paper 2. Allow me share the paper. Here is the paper. You can always engage through 07 5701 9011. You can go straight to the question 1. You're told that the following diagram shows the path of light after striking two mirrors at an angle. Then determine the angle between the two mirrors. As you can see, these are two mirrors that are inclined. Therefore, from your own imagination, then you can complete the diagram so that you can see at which side are these two mirrors in. I'll complete mine like this. That is the figure. Then the second one. Like that. Then, from the look of things, in this case, we can see that we are forming a triangle, that this is 20 degrees. Then now we should be asking ourselves, what about? Therefore, our theta will be given from the summation of all the angles in a triangle, which is 180 minus the sum of 20 plus the sum of 20 and 20. Therefore, 90 plus 20. And this gives us 180 minus 110. We'll arrive at 70 degrees, like that. The figure shows the eye defect. Then you're told to name the defect. If you look at this one, you can see that the image will be formed at this part. Then the kind of defect, which is this one, is called the long-sightedness. Long-sightedness. And this one is corrected by use of a concave lens, where we first try to diverge the rays, then they are converged by the high lens. This one is also called the diverging lens. Explain why a plane sheet and a plane mirror both reflect light, yet only the plane mirror forms images, while paper cannot form images. You know, plane mirror will always reflect the light rays, but since the paper is somehow rough, then it is going to absorb most of the rays. Therefore, you can say plain papers. Absorbs some light while the mirror does not, but reflects all the light. It reflects all the light. What property of light is suggested by the formation of shadows? Shadows are formed when light rays are blocked by an obstacle. A property that is being investigated in the formation of shadows is that light travels in a straight line, where we can say rectilinear propagation of light. We can say rectilinear propagation of light, or can also say centimeters from a convex lens image, which is magnified, and it is magnified 2 times. Determine the focal length of the lens. In this case, you can analyze the question where you can say the magnification is 2. Then we know that M is given by V over, and in this case, you can substitute where we'll be having our 2 is given by our V that we are looking for first over U, which is 15 centimeters. This one. Then now we're going to get V as 2, you arrive at 30 centimeters. But now we are told that this is a convex lens and it is forming an upright convex lens forming an, and it is of magnification. Therefore, we know that in this case our V is supposed to be negative 30 centimeters from the convention sign. Therefore, we can say using the lens formula 1 over F is equals to 1 over U plus 1 over V. Therefore, 1 over F is equals to 1 over 15 plus 1 over negative 30. We're supposed to see that negative 30. This will result as to 1 over F is equals to 2 minus 1 out of 30. Therefore, 1 over F is equals to 1 over 30. Therefore, our F is same as 30 centimeters. If you look at this one, we have given the condition under which a convex lens gives a virtual image when the object is placed between the F and the optical center O. State one advantage of a lead acid accumulator over the nickel ion accumulator. Then you can say this one has a higher EMF. Lead acid accumulator has a EMF per cell. An electric bulb rated 40 watts is operating at on 240 mils. Determine the resistance the filament of its filaments. Then in this case, you can say from the formula of P is given by I, then our 40, which is our power, is given by a voltage of 240 times, sorry, you can use another formula. You can go for the formula of V squared over R. Then our 40 will be the same as 240 squared over R. Therefore, our R is the same as 240 squared divided by 40. And in this case, we'll arrive at 1440. The other methods, the first one that I had given out, is a bit long, but I can still show it. This is the first. V is equals to IR. You can say now voltage of 240 is same as 0.0 0.67 times R. R will be the same as 240 divided by 0.1667. You're going to get a value of 49.7 ohms, which is equivalent to 1440 ohms. That is the second. Explain why earthing is necessary in the domestic wiring circuit. Earthing is done on the neutral wire, and the purpose of this one is to neutralize circuits. But now here we are being categorized, or the question is specific on the domestic wiring. So this one is the risk of electric shock, prevents the risk of electric shock in case of faulty. A positively charged rod is brought near the cap of electroscope. The cap is earthed momentarily by touching with the finger. The rod is withdrawn. The electroscope is found to be negatively charged. First, we are being told here is that it is just brought near a leaf electroscope. Therefore, this is charging by induction. And charging by induction, we do expect to have the opposite charge to the one of the charging body. Therefore, once this one is brought near the cup, then the positively charged rods so now we are in the next step of earthing. The electrons flow from earth towards the cup. And this is the cup of the electroscope. And they neutralize the positive charges. In elaboration, you can say that this is positively charged. It is brought near the cup the negative ones to be attracted here, and the positive ones to be repelled towards the leaf. Then now we try to touch. We try to touch like this. So now, how will the electrons charges move and in what direction? Our entire mission is to have this leaf electroscope being charged negatively because we are using induction method. Therefore, for us to remove these positive charges here, then we expect that electrons flow from Earth towards the cup. And it is in this manner where the electrons, which are negatively charged, will overpower the positive charges. Then we say they have been neutralized. The force on a conductor carrying current in a magnetic field can be varied by changing, among others, the magnitude of the current and the magnetic strength. Name any other factor that can be changed to vary the force. The remaining factor, we have the angle at which the conductor carries the magnetic. So we can say the angle at which the conductor carries so we expect maximum when it carries at 90. That is where we expect the maximum force. We can move now to question 11. The table below carries information on the type of radiation detectors of some of electromagnetic radiations. We have microwave. It is detected by use of crystal detector. We have solid diodes. Then what is the use for this one? It is used in one, we have in radar, the one for identifying the distance of aeroplanes from the space or from the atmosphere towards the earth. We have wireless. It is also used in wireless networks sensing. We have a type of radiation that has not been mentioned, but it is detected by use of a thermal pipe, a blackened bulb thermometer. Sensation. Warmth sensation is like the one used in the greenhouse. Then from the greenhouse, you can directly understand the type of radiation here is infrared. Infrared radiation. The figure below shows a convex mirror and a plane mirror of equal aperture. Then you are told by sketching a pair of incident and reflected rays in A and B, show how convex mirror provides the eye with a wider field of view than plane mirror. It is in this case where we say that convex mirrors are used in the supermarket because they do offer a wide field of view. Then now we have been given the comparison of this convex with the plane mirror. Therefore, we can draw the incident rays into these mirrors, and then once they are reflected back into the eye, what will or else how will they be like? But in this case, we are supposed to start with the first rays which are already reflected into the eye. But now we can make a reference from the law of reflection, where the incident angle must be equal to the reflected angle. For case 1a, here we go. From the eye, we can draw two rays like this. And now these, they are the ones that will converge at the, so that you can get an image. Then from the law of reflection, then the incident angle will be equal to the reflected angle. Then now from this, I can now draw my incident rays. For high levels of accuracy, it is always advisable you measure or you show the normals. This manner, it was incident. Then for the second case, we now have the reflected rays margin in this manner. Then now, from this point, now you can get the incident rays. Remember, these two are the reflected ones. Like that. Yes, like that. I may not have drawn it to the highest level of accuracy, but that is how it is supposed to go. I've drawn some dotted lines so that this one can guide you in this part. Therefore, from this case, we can say that the only field of this one, if you compare it to this one, then you find that one for plane mirror is very small. Now we can move on to the next question. Water is flowing in a very narrow water tap. A negatively charged plastic is held close to the stream as shown. Remember, this one is just being brought from the diagram. You can see that this stream of water is like it is being attracted towards the plastic strip. Then we are told the stream of water moves towards the plastic. That is attraction. Explain why this observation. Explain why this observation. In this case, since the strip has brought close, we can say it has induced opposite charges onto this stream of water. The negative charges induce positive charges by repelling the negative charges. Attractors. Another repeated concept, induction, charging a body by induction. Distinguish between transverse waves and longitudinal waves. This is now section B. Then we can go by. Transverse waves are characterized by the vibration of the ball causing the wave move perpendicular to the direction of the wave, while the one for longitudinal, it moves perpendicularly to the direction of the wave. Therefore, now you can say transverse waves is a wave in which the particle causing the wave move perpendicularly to the direction of wave. How? If this is the particle, it can either move up or down, then it will cause a wave to move in this direction. While a longitudinal wave, the particles, the wave move the direction of the wave. In a swimming pool at a velocity of 4 meters per second, if the wavelength of these waves in deep end is 5 centimeters, determine the velocity of these waves in the shallow end. The first thing to note about waves from a deep have higher velocity in the deep end and a decreased velocity when they come to the shallow end. Therefore, velocity varies, frequency remains constant, wavelength varies. How? From deep end, there will be higher velocity. To the shallow end, there will be a lower velocity. The same applies to wavelength. You have a higher wavelength or larger wavelength in and a smaller wavelength in the shallow end. Therefore, if we compare the velocities in deep, velocity in the shallow, then now we use the wavelength. Where we can the wavelength here and the deep end is 6 divided by 1.5. Now you can say from this ratio 4 meters divided by the velocity in the shallow end is given by 6 out of 1.5. Then our velocity Vs at the shallow end will be given by 4 4 times 1.5 divided by 6. And this will direct us to 1 meter per second. Therefore, the concept of from deep end towards the shallow end, we expect the velocity to decrease is being manifested in this question. It states one factor that affects the velocity of sound in a solid. We all know that factors affecting velocity of sound in air, but now in this case, the question is specific. We are in a solid. Therefore, we have temperature of the solids. And then we have the density of the solid. As you increase temperature, we expect the velocity of sound to also increase. An increase in density of the solid, we also expect the velocity of sound to also increase. And this siren with 200 O's is rotated at a constant making 0.5 revolutions per second. If air is blown towards the O's, calculate 1. The frequency of the sound produced. This one is given by the number of revolutions of O's. Therefore, say frequency is given by number of revolutions, so that you can arrive at 100 hertz. 100 hertz. Roman 2, the wavelength of the sound produced if the velocity of sound in air is 340 meters per second. We can use the formula of velocity is given by F lambda. Therefore, 340 is equals to a frequency of 100 meters, of 100 hertz multiplied by lambda. Therefore, making lambda the subject of the formula, it becomes 340 divided by 100. In this case, we arrive at 3.4 meters. That becomes our wavelength. State one way of reducing echoes in a room. This is called the effect of reverberation in a house or in a room. And this one can be reduced by applying or using materials on the walls, materials that do absorb sound. Say, covering seats, the walls, and the ceiling. With sound absorbing materials. G, materials made of rubber and wool. State one advantage of alkaline accumulator over lead acid. This may appear like a repetition, but it is not. Therefore, you can go straight to the responding or to the responses. We have alkaline accumulator. This one you can say large amounts of current can be withdrawn within a very short period of time. Next, with ease, keep on checking the level of the acids, the density of the acids. This one, there is nothing to do. Then you can also say that can stay for long time. In uncharged condition. The figure below shows two resistors in a circuit. You are told calculate the current through the 4 ohm resistor. So we have a potential difference here of 3 volts. We have an ammeter here. This is a 3 ohm resistor, 6 ohm resistor, and 4 ohm resistor. 3 ohm and 6 ohm, they are in parallel connection, but their entire effective resistance is in series with the 4 ohm. Then now we are asked about the current through the 4 ohm resistor. This one is like calculating the total current that is leaving the cell. Therefore, first thing we get the effective resistance. So RT will be given this one and this one, they are in parallel connection. Therefore, 6 times 3 divided by 6 plus 3. Then its entire effective resistance is now in series with the 4 ohm. Then I add my 4. This means 2 plus 4, which is same as 6 ohms. Then we know from the Ohm's law, V is equal to IR, where we can say our voltage, which we had already seen that it is 3, is the same as 6 times R. Making R the subject formula, R will be 3 divided by 6. The graph below shows the voltage current relationship for a certain bit. You are given this one. This is potential difference against current. Then this one, we can get this one from the formula of getting EMF, which is V plus IR. But in this case, our V is the subject of the formula, which is V is equals to E minus IR. If we relate this equation to Y is equals to mx plus c, then our V will automatically become or represent the Y. We can see the quantity on x-axis is current, then the value with current is negative IR, meaning that our I will represent our X, then our negative R will now represent M. Then our C will go for E, which is our EMF. Therefore, this means that the y-intercept will give us the EMF of the cell. We can go on. This is an incomplete graph, therefore you are entitled to complete it so that you can be able to respond to the questions being asked. Therefore, like that. I'm being asked about the EMF of the cell. You have said that EMF y-intercept. Y-intercept is reading from the scaling of this one small scale is representing 0.05. Therefore, this is 1 square, 2 squares, and now we can read it as either in between or the next value. So the next value will be 3 small squares, and this is 3 times 0.05. This will be 0.15, then plus 1.5, arrive at 1.65 volts. Therefore, our this part, which is our y-intercept, is reading for us 1.65 volts. Then the next question, the internal resistance of the cell. In this one, we are being entitled to get the slope. Remember, the slope of this graph is negative, and the negative slope will be giving us negative r. Therefore, picking 2 points in this manner, for example, picking a point in this part and the other point which is here. Then now I will draw some dotted lines to indicate where my points. Like that. Then now this will change in y and this is change in x, the quantity in x. Therefore, we can calculate the slope, which will be given by this is 1 minus this part is 0.25 divided by these parts here minus 0.35, and this is going to give us, I would carry all these value all the way to this part, where we'll say that the slope 5 over 0.16 minus 0.35, you get 0.75 divided by negative 0.19. So our slope is negative 3.947, but slope is equals to negative r. Therefore, negative 3.947 is equals to negative r. So our r is the same as 3.947 ohms. Two coils T and S are wound on a soft iron core as shown. T has 1000 turns and S has 600 turns and resistance of 100 ohms. So in this case, we can first analyze the question. You can say this is the primary coil and this is the secondary coil. Then V for primary is ms250 volts. V for secondary is unknown. Number of turns in the primary are 1000. Number of turns in the secondary are 600. Nothing else we have been given apart from the resistance of the wire. Then now you are being asked, what will be the maximum current? We do not have the current for primary. We do not have the current for secondary. But how will we arrive at getting the current of secondary? We can go through this simple method where we can say our N of secondary over the number of turns in primary is given by the voltage in secondary over the voltage in primary. It's also equivalent to current in primary over current in secondary. Then from here, we can first get the voltage at the secondary. Is becoming the formula multiplied by 600 divided by 1000. Vs is equals to 150 volts. Then now from here, you can use the and say that from V is equals to IR, then 150 and that we did not know, we can speak that it's the secondary 10 times 100. Our R becomes 150 times 150 divided by 100, and this will lead us to 5 amperes, like that. The figure below shows a simple form of cathode ray tube. It uses a sharp shadow of T's cross on a fluorescent screen. Then you are asked, what is meant by cathode rays? You all know that this is just a stream of electrons or a beam of electrons. Therefore, we can define it as is a stream of electrons, is a stream emitted from the surface of a metal or it That means we have the process of eating that is causing the dislodging of electrons from a metal surface. Getting back to this diagram and the question that is Roman 2, where we are being asked what property of cathode rays does the figure above illustrate? This stream of electrons or beam of electrons, it has been blocked so that a shadow is formed. Remember, a shadow is formed when a rays or a beam of electrons are blocked by an obstacle. This means that either the electrons do travel in a straight, therefore, can say they travel in a straight line. They travel in a straight. So once you block them, then they will trace the kind of objects effects photoelectric from a given metal surface. We have three factors. One, we have the density of radiation. Number two, we have energy of radiation. And number three, we have type of metal. This is just setting. Kinetic energy, a graph of kinetic energy of photoelectrons emitted by metal surface against the frequency of radiation. Use as a frequency. The most of the times we do get graphs of stopping potential against frequency. Trust me that this is the modest analysis from the photoelectric effect or emission. Therefore, I'll discuss this one and I'll give some small differences. Stopping potential against for stopping potential. Stopping potential. Yeah. So this is in watts and this is frequency. F times 10 raised to the power 14 hertz. And they all do behave in the same manner. But now the difference comes on the analysis. This we should say that given by the work function plus kinetic energy. We can say that this one is HF is equals to HF naught plus KE. Using the equation of a straight line, y is equals to mx plus c. Then our KE, since it is the one that is on the y-axis, we should make it minus HF naught. Then our X will stand for F. Then our M will stand for H. Then our C will carry the whole of this part. Therefore, we can say our slope in this case gives the Planck's constant. Then our constant, our y-intercept, it is giving us negative KE. Since the value that we'll be reading here will be in negative value of KE, then now this one is, we can call this one to be negative work function, like that. Sorry, so I'll delete this one. So this one will be giving us negative work function, like that. What about this one? This one will say that energy of a photon, kinetic energy. Kinetic energy can be given in two ways, by electron volts or by half MeV squared. Therefore, this is HF is equals to HF plus EV. And since the V is the one that is on the y-axis, we carry this part to make it the subject formula. Therefore, EV will be the same as HF minus HF naught. V will be HF over E minus HF naught over E. That is dividing across by E. Then, to make this one to match the equation of to mx plus c, then negative HF naught over E will be giving us the reading here. Therefore, we can say and deduce that our slope is ms h over E, whereas our y-intercept which over E. Therefore, if you read it directly, then it will be giving you work function in electron volts. But now, if you find E, then it in joules. So, NB of y-intercepts gives work function in electron volts. That is something that you're supposed now to get. Now, this one was by the way. Let's get back. The question requires us in this part. What is the significance of the gradient? We have already seen that it is giving us the Planck's constant. So you say the Planck's constant. What is the significance of OX? This is like saying the y-intercept which is giving us our work function. This is the y-intercept. And we have seen that it is giving us the work function. You're told the threshold frequency for potassium is 5.37 times 10 raised to power 14. When the surface of potassium is illuminated by incident radiation from a source, photoelectrons are emitted with a speed of 7.9 times 10 raised to power 5 meters per second. Given that Planck's constant is equal to 6.62 times 10 raised to power 34. Supposed to be negative 34. It is seen from very far. Negative 34 joule seconds. And the mass of electron is 9 times 10 raised to power negative 31. Calculate the work function of potassium. Then we know that work function is given by HF naught. Therefore, this is 6.62 times 10 raised to power negative 34 times the threshold frequency we have been given as 5.37 times 10 raised to power 14 hertz. And this will lead us to 3.55 times 10 raised to power negative 19 joules. The frequency of the radiation from the second source. In this case now, we have to keenly. We all know that energy of a photon is given by the work function plus Ke. This becomes Hf minus is equals to work function plus kinetic energy is given by half mass of the electron velocity squared. That is the maximum velocity. Therefore, we have already the work function tushapata. Therefore, times 10 raised to power negative 34. Times F is equals to work function, which is this 3.55 times 10 raised to power negative 19 plus our v squared, which from the question we have been given as 7.9 times 10 raised to power 5 meters per second. So now I can complete my substitution. Times 7.9 7.9 times 10 raised to power 5. Then it is squared. This will be, this whole part will be standing for 2.843 times 10 raised to power negative 19 plus 3.55 blah blah blah. This will lead us to a total of 6.62 times 10 raised to power negative 34 F is equals to 6.393 times 10 raised to power negative 19. Therefore, making F the substitute formula, we have 6.393 times 10 raised to power negative 19 divided by 6.6, sorry, 6.62 times 657 times 10 raised to power 14 amps. That is the incident radiation. The figure below shows features of X-ray, and then look at it clearly. This is a lead shield. This is the anode, sorry, cathode. This is the filament. This is now the X-rays. A metal target, the anodes, copper anodes. We have cooling fins. Anything else that has been left out is a stream of electrons. Stream. This part is evacuated. Then how we can proceed to the question. Name the paths labeled with the letters A and H. A and H. So A is for cooling fins, cathodes. Remember, it is at the cathode where we have the issue to do with eating or current due to the filament, eating current in the filament. Then electrons will be dislodged, be accelerated towards the anode, and it is in the anode where we have the metal target, a material that is of very high melting points, which converts now this beam or stream of electrons into X-rays. So this tells us that if you have cathode rays and then you direct them into a metal target or molybdenum, metal most suitable materials for making part C. Part C is of the metal target, and we expect the beam of electrons or the electrons that will be hitting there. Expect a lot of heat to be produced. Therefore, They are materials that are of high melting points. They have high melting points to withstand why is part B made of thick copper? Part B is anode. If you look at it, it is connected, or we are having the tungsten or target there. It is attached to this copper anode. Then, what could be the reason? Remember, we have said the materials making the metal targets are of very high melting points, meaning that there will be production of a lot of heat, and it needs to be emitted away. Therefore, the function of this one, it is thick to ensure efficient dissipation of it. Why should the of radiations and therefore it will be of used in this part. Remember, X-rays, they have side effects to the operators. Therefore, we need to protect them. We need to guard them from what we call stray X-rays. These stray. So, to absorb which would be affects the X-ray tube operators. Remember, these streams or these electrons, they need to move very fast. Therefore, if they interact with materials, then they are likely to lose their energy. Therefore, they travel in an evacuated path to ensure that they do not interact with any material. Therefore, they will conserve all their energy. Prevent electrons from losing energy by interacting with air particles or molecules. And this can also cause ionization. Increasing current of F on X-ray produced. What is F? F we do affect quantity. The X-rays produced. And if you increase the quantity of the X-ray produced, then you do bring about what we call the add. Sorry, we expect to increase of the X-rays. Sorry, because the muonic emission will also increase. Therefore, we can say this increases the temperatures is like eating. Therefore, the muonic emission, don't bother about the spelling there, will increase dislodged. Potential difference will affect the quality. Potential difference will affect the quality. So if you need potential difference, then you're going to produce add X-rays. So you can say add will be produced. And they are of shorter. If you can decide to describe them. State one way in which the cooling is achieved in the X-ray machine. We had already mentioned about the cooling fins, and from the diagram we can also see a part where we are having some oil leaving, so that is getting in and leaving. So we have this oil in and out, then we have the cooling fins. We can use those two mechanisms. One, we have plating of oil. Then we have the cooling fins. Set one difference between a capacitor and a cell. A capacitor stores charges, while a cell while a cell converts electrical energy, chemical energy to electrical energy. Like that. Question 18B. Sketch the electrostatic field pattern due to the arrangement of the charges shown. That is negative or the positive. Therefore, we expect electrostatic field lines to flow from the positive charges towards negative charges. Then you indicate the direction in which they are moving in, like that. This is a parallel plate capacitor with a dielectric material in between the plates. States, you can see where the dielectric material is. State how the following quantities are affected when the dielectric material is pulled out of the parallel plates. The potential difference. This one increases. The charge on the plates, they will not be affected, therefore they remain the same. The capacitance of the system, entirely this one is going to reduce because we have seen that the potential difference is going to increase. Sorry, the capacitance of the system. Capacitance of the system is equals to this one is going to decrease because we have said capacitance is given by Q over V. Then increasing the denominator means that this one is going to go down. Three capacitors, microfarad, sorry, 1.5 microfarad, 2.0 microfarad, and 3 microfarad are connected in series to a potential of 12 volts. Find the total charge stored in the arrangement. Therefore, I can say that C total, or else the effective capacitance would be 1.5, sorry, that is 1 over CT will be 1 over 1.5 plus 1 over CT is equals to 1.5. Therefore, CT is equals to inverse of 1.7 microfarad. Like that. Then you are asked find the total charge. Charge is given by capacitance times of what? Therefore, this will be 0.6667 and get your answer here as 0.6667 times 12 get 8.00, arrive at 8.00 0 microcoulombs. This is like saying 8.0 times 10 raised to power negative 6 coulombs. What would be observed for the following when the switch is closed? We are having that diagram there. So once the switch is closed, we expect current to be flowing. So what will be happening to the milliammeter? At first, it is going to make a very high reading, then it will come back to zero. Why does it come to zero? Because we have a body that is a capacitor which is being charged there. Therefore, the milliammeter first makes a very high reading. Then falls to zero. What about the voltmeter reading? Remember, this is a capacitor that is being charged, and we do expect all the potential difference that is in the cell to be transferred to the capacitor. So we do expect the voltmeter reading here to increase 5 watts. Explain how a capacitor is charged. This will be a narration. Therefore, just need to go straight to the narration. Then you can say yes, negative charges from negative terminal the battery flow connected to it. At the same rate, positive charges flow from float. positive, and negative charges sets a potential difference. On the axis, sketch the graph of V against T. We expect the voltage on the capacitor to be increasing. Then we can say that it should come to a maximum of 4.5 volts. That marks the end of the paper. Thank you so much. Blessings. Still pin my number. Thank you.